Good morning and welcome you all. In the last lesson, I have discussed the concept of differentiability and the problems which we are going to solve. For that, the formula of the differentiation I have already discussed with you in the last lesson. Today, I will bring the problems of exercise 5.2. Right? In the 5.2, we have to find the differentiation of the different given function. And for finding the differentiation of different given functions, the basic formula of differentiation, I have written in the last lesson. The first question is sine x square plus 5. Sine x square plus 5. Let y is equal to sine x square plus 5. Now we will write differentiate with respect to x. Differentiation of y with respect to x, I will write dy by dx is equal to dy dx of sine x square plus 5. Right? It is sine x square plus 5. Differentiation of sine x is what? Cos x. So now differentiation of sine x square plus 5 will have cos x square plus 5. And since it is not only x, it is x square plus 5, that's why now we will differentiate x square plus 5. Now this I will write cos x square plus 5 into differentiation of x square plus differentiation of 5. So now d by dx of x square plus dy dx of 5. Right? Now cos x square plus 5 and differentiation of x square is the formula n x to the power n minus 1 function, right? Function to the power into function power minus 1, that is 2 into x to the power 2 minus 1 into differentiation of x is equal to 1 plus differentiation of constant term is 0. That's why what we have got now, here it is 2x into cos x square plus 5 is the differentiation of sine x square plus 5. Right? Next question. Question number 2. Question number 2 is cos of sine x. Cos of sine x. Let y is equal to cos sine x. Now differentiate with respect to x both the sides. You get dy by dx is equal to dy by dx of cos sine x, and we know that differentiation of cos x is minus sine x, then I have minus sine, in place of x we have sine x, so minus sine x into differentiation of sine x, this part is left, and differentiation of sine x is what? Cos x, but let's explain here cos x first, so now minus cos x into sine of sine x is the differentiation of the given function, right? That is y is equal to cos of sine x, right? Now next question, number 4, right? Therefore, we have find the differentiation of sec tan under root x. Sec tan under root x. Sec tan under root x. Right. Let y is equal to sec tan under root x. Here y is equal to sec x. In place of x, what we have? Tan root x. So now y is equal to sec x. Differentiate both the sides with respect to x. Differentiate with respect to x. Both the sides. dy by dx is equal to differentiation of dy by dx of sec tan under root x. Differentiation of sec x. Differentiation of sec x is what? Sec x into tan x. Now let's sec, in place of x we have tan under root x, sec x into tan under root x into differentiation of tan root x. Right? Sec x into tan x. In place of x we have tan root x. That's why sec x into tan x into differentiation of, now this part is left, tan root x. Tan root x. Now these two functions will remain as it is. This is equal to sec tan under root x into tan under root x into differentiation of tan x. Differentiation of tan x is sec square x. Differential of tan x is sec square x. So now sec square under root x. Differentiation of tan root x is sec square root x. Now differentiation of tan root x. dy by dx of root x. So now again first, second and third term will remain as it is. Sec tan under root x into tan under root x into sec square root x. Now differentiation of dy by dx of root x. Root x I can write what? X to the power 1 by 2. X to the power 1 by 2. That's why we'll go the formula x to the power n. Differentiation of x to the power n is equal to n x to the power n minus 1. Here power is 1 by 2. That's why power is power into function power minus 1. That means 1 by 2 and x to the power half minus 1, that is minus half, that is under root x. So now can I write this? 1 upon 2 under root x. 1 upon 2 under root x into sec tan root x into tan root x into sec square root x. This is the solution, or this is the differentiation of y is equal to sec tan under root x. Right? Now the fifth question is find the differentiation of sine ax plus b, sine ax plus b upon cos cx plus b. Sine ax plus b upon cos cx plus b. Right? Let y is equal to sine ax plus b upon cos cx plus b. Differentiate both the sides with respect to x. dy by dx is equal to dy by dx of sine ax plus b upon cos cx plus b. Here, if you remember, we'll apply the rule of differentiation of the quotient rule, f upon s. That means differentiation of first, second entities minus differentiation of second, first term entities divided by the second term's whole square. That means this is equal to d by dx of sine ax plus b into cos cx plus d as it is minus cos cx plus d into the differentiation of cos cx plus b into sine ax plus b whole divided by cos cx plus b whole square. Now, differentiation of sine ax plus b will be what? Cos ax plus b, and again we'll have to differentiate ax plus b. The differentiation of ax plus b will have simply a. So that's why what I do first, I write this term cos cx plus b into differentiation of sine ax plus b is cos ax plus b into differentiation of ax plus b, right, minus, I like this part first, sine ax plus b into differentiation of cos cx plus d. Differentiation of cos x is minus sine cx plus d. Now this minus and this one becomes plus sine cx plus d into differentiation of cx plus d whole divided by this. Now can I write cos square cx plus d. Now I write the final answer. Differentiation of ax plus b, that means differentiation of ax plus differentiation of b. Differentiation of b as a constant term, b is a constant term, the differentiation will be 0, and differentiation of ax will be a. Differentiation of ax will be a, because a is a constant here and x to the power 1. That's right, that will differentiation of x will be 1. Therefore, simply a we have. And now what will I write here? A into cos cx plus d into cos ax plus b minus, and it becomes plus differentiation of cx plus d will have simply c into sine ax plus b into sine cx plus d and whole divided by cos square cx plus d, and that will be the differentiation. Even we can bifurcate it two places also, a into cos cx plus d into cos x plus b whole divided by cos square cx plus d plus c into sin ax plus b into sin cx plus b divided by cos square cx plus d. So you can get the answer in two parts also, right? Now the next question. Next question is cos s square cos x cube cos x cube into sine cos x cube into sine square x to the power 5, sine square x to the power 5, right? Cos x cube cos x cube into sine square x to the power 5. There are two terms. Now let y is equal to cos x cube into sine square x to the power 5. If you remember, f into s, first term and the second term, right? First term is here cos x cube, second term is sine square x cube, sine square x to the power 5. Now differentiate with respect to x. dy by dx is equal to differentiation of d by dx of cos x cube into sine square x to the power 5 as it is. Sine square x to the power 5 as it is plus now cos x cube will be as it is, cos x cube will be as it is, and the differentiation of sine square x to the power 5, right? Now first I'll write this part, sine square x to the power 5 into differentiation of cos x cube will be, differentiation of cos x is minus sine x, that's right, minus sine x cube. Now again differentiation of x cube will have 3x square, right? Sine square x to the power 5 here written. Differentiation of cos x cube is minus sine x cube. Now x cube is left, differentiation of x cube will have 3x square, right? Plus cos x cube into differentiation of sine square x to the power 5. Here sine square x to the power, it's not sine x to the power 5. Sine square x to the power 5. That means first of all we have to apply the formula x to the power n. That is sine x to the power 5 to the power 2. That is what? 2 into sine x to the power 5 whole to the power 2 minus 1, right? And after that we will go for, see, first I will done sine x to the power 5 whole to the power 2, whole to the power 2, a square is there, that's right, power into function power minus 1, x to the power, differentiation of x to the power n, x to the power n, here x is sine x to the power 5, so now n into x to the power n minus 1. Now differentiation of x to the power 5, differentiation of x to the power 5. So now here I write minus 3x square into sine square x to the power 5 into sine x cube plus 2 into differentiation of 5x square will have 5x to the power 4, 5x to the power 5, 4, 5 into x to the power 4, can I write here? Differentiation of x to the power 5, x to the power 5, here power into function power minus 1, 5x to the power 4, 2 already I have written, now I am left out with cos x cube into sine x to the power 5 to the power 1. Now I write the final answer, minus 3x square into sine square x to the power 5 into sine x cube plus 10 x to the power 4 into cos x cube into sine x to the power 5. Right. Here the answer is given as, we can write also this positive term first, tan x to the power 4 into cos x cube into sin x to the power 5 minus 3x square into sin square x to the power 5 into sin x cube. This change you can do, otherwise let it be like this only, right? Tan x to the power 4 cos x cube into sin x to the power 5, right? Now the next question is question number 7. Question number 7. 7 we have y is equal to 2 under root cot x square. 2 under root cot x square. Y is equal to 2 under root cot x square. Let y is equal to 2 under root cot x square. Right? We have to find the differentiation of 2 under root cot x square. Right, differentiating both the sides with respect to x. Differentiating with respect to x. Dy by dx is equal to 2 into d by dx of cot x square to the power 1 by 2. Under root cot x square, there is first x to the power n. X to the power n. This will be 2 into power into function into power minus 1 into differentiation of cot x square. Now this will give you 2 and 2 is cancelled. 1 upon under root, because cot x square to the power half minus 1, half minus 1 is minus half. That means under root cot x square cot x square into differentiation of cot x square. Differentiation of cot x square will be what? Minus cosec square. Minus cosec square. Minus cosec square x square. Yes or no? Now, what is left? X square is left again. Differentiation of x square is how much? D by dx of x square. Now, can I write minus cosec square x square into differentiation of x square is equal to 2x, and write here now minus 2x upon under root cot x square. So now here the answer is minus 2x into cosec square x square whole divided by under root cot x square. We can go further also. If you want to go for the next step, can I write minus 2x into cosec square x square? I can write 1 upon sine square x square. Any problem? Because you know that cosec x is equal to 1 by sine x. Here cosec square x square is equal to 1 by sine square x square, and here denominator is under root cot x square. Under root cot x square, what you can write? Under root cot x square, you can write under root cos x square divided by under root sin x square. It means here can I write under root sin x square, can I write? Now here under root sin x square, and here is sin square into x square. Means what? Sin square x square under root sin x square, or here sin square into x square. Now tell me what we have. Minus 2x into under root sin x square right. Here we have sin square x square. Can I write here now sin x square into sin x square, right, into under root cos x square. Can I write or not? Can I write? So now under root, you know that under root sin x square into under root sin x square, we will have under root sin x square into under root sin x square, we will have sin x square, isn't it? Therefore, this part will have 2x minus 2x into nothing left out. This part will have cancelled. and I'll write here under root sine s square. Now under root sine x square into cos x square, and 1 sine s square will be left out into 1 by sine x square, isn't it? 1 under root sine x square into under root cos x square, and 1 sine x square will be left out. Now 1 by sine x square, this can I write now minus 2x into 1 upon sine x square is what? Cosec x square whole divided by under root sine x square into cos x square. Now tell me sine x square into cos x, sine x into cos x, we don't have any formula. But if we have under root 2 into sine x to cos x, we can have the formula. That's what I am going to do. I am going to multiply by root 2 both the sides. That is 2 here and 2 also here I write into root 2. So now what I will get? Minus 2 root 2 minus 2 root 2 into x into cos x square whole divided by under root 2 sin x into cos x is equal to sin 2x. Then I write as sin 2x square, and that can be the answer which is there in your book. Or we can leave up to this step also. This is also right, no problem. Right? This was question number 7. Now question number 8 is find the differentiation of y is equal to cos under root x. First differentiate cos under root x. Cos under root x will give you minus sin under root x, and after that we define the derivative of under root x. That will have minus 1 by 2 under root x. That's why we will have the answer minus sin root x upon 2 root x. Now I am going to do the last question of this exercise. The question is question number 9. Prove that the function f given by question number 9. Prove the function given by y is equal to f of x. Y is equal to f of x is equal to mod x minus 1. Mod of x minus 1, x belongs to real number r, is not differentiable at x equal to 1. Right? That means we have to check the differentiability of the given function f of x is equal to mod x minus 1 at x is equal to 1. And if you remember, we have discussed that whenever we are asked to find out to check the differentiability of any functions, then we check it by two ways, LSD and RSD. LSD and RSD. Here I have to check the function f is differentiable at x is equal to 1 or not. That means I have to check the differentiability of f of x at x is equal to 1. I have to check. That means I have to find out the left hand derivative and right hand derivative. If both are equal, left hand derivative and right hand derivative, if both are equal, then we can say yes, this function is differentiable. Now LSD, if you remember, L f dash of 1, because here I am checking going at 1, is equal to limit s tends to 0 f of 1 minus h minus f of 1 upon minus h. If you remember, I made you to write the formula, isn't it? Here suppose I have to check it at c. So now f of c minus h minus f of c upon minus h. Now here f of 1 minus h, f of x is x minus 1. F of x is x minus 1. Now x will be replaced by 1 minus h. So now what I will get? limit h tends to 0, f of 1 minus s is equal to mod 1 minus h minus 1 minus f of 1 will have 1 minus 1 whole divided by minus h. This will give you limit h tends to 0, 1 minus 1 cancel, mod of minus h, simple h, minus 0 upon minus h, and that is equal to limit h tends to 0, h upon minus h is equal to minus 1, and h is equal to minus 1, right? Now the right hand derivative that is equal to r f dash of 1 is equal to limit h tends to 0, f of 1 plus h minus f of 1 upon h we write. Now this is equal to limit h tends to 0, f of 1 plus h is what? 1 plus h minus 1 minus 1 minus 1 plus h, f of 1 will be 1 minus 1 whole divided by h, and that is equal to limit h tends to 0, 1 plus h minus 1, that is h minus 0 upon h is equal to limit h tends to 0, h upon h is equal to what? 1. See, left hand derivative is minus 1 and right hand derivative is 1. Since LSD is not equal to RSD, and hence it is not differentiable. It is not differentiable at x is equal to 1. Similarly, we can do the second part of the questions. And now this exercise 5.2 is complete. By the way, there are so many problems, there are so many things. We cannot have notebooks, we don't have the facility to take books and notebooks. That's why I'm not giving the assignments, but please honestly go through the questions, okay? And please keep on doing the practice as much as you can, okay? And in the next lesson, I'm going to start with the 5.3. But before 5.3, I think maybe 1 or 2 concepts also I will discuss. Thank you. Have a nice day. Enjoy your day. Thank you very much.